Hello Year 9. Today's learn objective is to know how to truncate different types of number, and we're going to go through what that word truncate means in a moment. Please write the learn objective in your books. You'll notice on the board are your 6 starter questions. Please pause the video here for 10 minutes and work through those 6 questions. Have a green pen ready because we'll go through the answers in a moment. So pause the video now please to work on that. So 6 answers to the starter, all on the board. Please mark in green pen and be ready to move on to the next I do and we do. So pause the video here while you mark that and then be ready to move on. So truncation, we come to our first I do and we do, and the first example is asking us to truncate to 4 decimal places. Now what it means to truncate to 4 decimal places, essentially it means we count up to 4 decimal places, so we've got 43.5 is 1 decimal place, 2 decimal place, 3 decimal place, 4 decimal place is this number 4 decimal places. And when it says truncate to 4 decimal places, it essentially means we're going to draw a line after 4 decimal places and ignore everything after that. So our answer is 43.5634. Notice how this is a 6 and you might want to round up this 4, but that's not the case. We're truncating. So everything after 4 decimal places we ignore. So ignore this 6 and we keep the first 4 the same. Please pause the video here, copy that down and then round and truncate the we do to 4 decimal places. So remember, ignore everything after 4 decimal places. So 72.68439. So 4 decimal places, we've got 6843, there are 4 decimal places, and we ignore everything after the 3. So the 9 doesn't round up this 3, we ignore it. So truncate means to ignore everything after that. So our answer should be 72.6843. Ignore everything after the 3. We'll move on to some different examples now. So this time we're truncating to 1 decimal place. So 43.56346. So really easy. 1 decimal place is this 5 here, and we ignore everything after it. So this 6 doesn't round up the 5, we just ignore everything after 1 decimal place. So imagine drawing a line and then just chopping the rest of the numbers off. 43.5, that's our answer. Please truncate 72.68439 to 1 decimal place. Pause the video now, do that yourselves. So 72.68439, we're truncating to 1 decimal place. So the 1 decimal place is this 6. So we draw a line after the 6 and we chop off and ignore everything after the 6. So our answer is just 72.6. Okay, so getting a little bit trickier now, truncating to the nearest 10. So what this means is, after this 4, this is the tens column, okay? So after this 4, we draw a line and we ignore everything after that. So the nearest 10 is 40. Ignore everything after the 4. So 4 in the tens column, that means it's 40. Please pause the video here and try the we do for yourselves. Okay, so 72.68439, and we're truncating to the nearest 10. So look at the tens column, that's our 7. Draw a line after that 7. So we've got 7 in the tens column, we ignore everything after that, so this truncates to 70. You see, even if we had a 6 here, if it was 76, truncating to the nearest 10, we'd just draw a line after that 7. It's in the 7 for the tens column, so it'd still be 70. So yeah, give yourself a tick and green pen if you've got 70 for that. Well done. Okay, example 5, truncate to the nearest integer. Now remember, integer means whole number, so we're truncating to the nearest whole number. So essentially 43.56346. We just chop off everything after the decimal place. So we want a whole number, so we only want these 2 digits. We don't want any decimals. So chop off everything after the decimal, so we just have 43. So truncate this to the nearest integer. Pause the video here for a minute or so. Truncate that to the nearest integer. So 72.68439. Chop off everything after the decimal and we get 72. So that's our answer. We'll move on to some independent practice now, so please be ready to try some questions for yourselves. Okay, so question 1 says truncate 9840.58976 to the specified degree of accuracy. So A asks us to truncate to 4 decimal places, so count 4 decimal places, chop off everything after that. And then B is 3 decimal places, so on, so on. See if you can do those 8 questions. Pause the video, 10 minutes, work through those 8. Be ready for the answers. So pause the video now. Okay, so your 8 answers to those questions we just looked at. Mark them in green pen, have a look. Did anyone get 8 out of 8? Because that's really good if you did. We're going to move on to something slightly different now for the remainder of the lesson. So that was truncating. Well done if you're getting that right. Okay, so for the rest of the lesson, we're going to have a taster of error intervals, and this will be the focus of next lesson. So I'll show you some for today's lesson. So error interval. So it says a number x is rounded to the nearest 100. Write down the error interval for x. So x has been rounded to 400. And we've got to come up with all the possible values x could have been. And we're going to write this as an inequality. So if you imagine, if a number's rounded to the nearest 100, you've got to think of all the numbers it could have possibly been to round to 400. So it could have been as low as 350, because 350 would still round up to 400. 349 would round down to 300, so it can't be 349, but it could be 350. And then think on the high end of the scale, 400. Well, it couldn't have been 450 because that would round up to 500, but it could have been 449 or 449.999. That would still round down. So we're going to write this as an inequality. All the numbers that could have rounded to 400 to the nearest 100. So we're going to write 350 as the lower bound, and x could have been more than or equal to. Remember, this sign means more than or equal to. So x could have been equal to 350 or more than 350. And on the high end of the scale, 450, well, x could have been anything less than 450, not including 450. That would round up to 500. That's why we've just got a less than sign here. So x could have been anything less than 450. So for the we do, x has been rounded to the nearest 100 to 700. So what numbers could it have possibly been to round to 700? Write it as an inequality here. So please pause the video, copy down the I do, and then do the we do. So pause the video now and we'll go through the answer afterwards. So to round to 700 to the nearest 100, it could have been anything as low as and including 650. That's why we've got more than and equal to. And it could have been anything lower than 750. That's why we've got the less than sign for 750. Give yourself a big tick and green pen if you got that right. Okay, so a number x is rounded to the nearest 10 this time, and it's equal to 400. It rounded to the nearest 10. So let's think what numbers it could have been. So 395 is the lowest number that to the nearest 10 would round up to 400. And that's including 395. So 395 is going to be our lower bound. And x can be anything more than this or equal to. And then on the upper bound, well, 401 would round down to this, 402, 403, 404. 405 would round up to 410 to the nearest 10. So it can be anything less than 405, not including this. Hence why we've just got the less than sign. Please do the same for 700. Pause the video here, do the same for 700. Okay, so for 700, x could have been anything equal to or greater than 695 and less than 705. Well done if you got that right. One last I do and we do, and then we'll give you some questions to try it yourself. So a number x is rounded to the nearest integer. Remember, this word integer means whole number. So a number x is rounded to the nearest whole number, and that whole number is 4. So every number that rounded to 4, that could have rounded to 4 to the nearest whole number. So lower bound is 3.5. 3.5 would have rounded up to 4, so it includes 3.5, so anything greater than or equal to 3.5. And then on the upper bound, 4.5 would round up to 5, so it could be anything less than 4.5, because anything lower than 4.5 to the nearest whole number would round to 4. Please do the same for 7. So for 7, rounded to the nearest integer is rounded to 7. It could be anything greater than or equal to 6.5 and less than 7.5. So well done if you got that right. We'll go on some independent practice now. Okay, so on the board you have question 1, question 2 and question 3. Question 1 says a number x is rounded to the nearest 100. So these numbers have been rounded to the nearest 100. Write down the error interval. So all the numbers in an inequality that could have rounded to each of these numbers. Question 2, these numbers have been rounded to the nearest 10. So write an inequality for every number x could have been to round to this number to the nearest 10. And then the bottom one, question 3, these numbers have been rounded to the nearest whole number. So write the inequalities for every number that these could have been to the nearest whole number. So for your answers, there they are on the board, so please mark them now. Pause the video while you mark that. Thank you for listening today, Year 9. We'll build on these skills in next lesson, so thank you for listening and I'll see you again soon. Goodbye.